Okay, so we are now on the database normalization. Okay, so as I have mentioned in our previous video, we are going to discuss on database normalization as our solution for the database anomalies that we have discussed. Okay, so what is database normalization? Okay, so it is the process of structuring a relational database to reduce data redundancy and improve data integrity. So, as you have observed into our previous video on database anomalies, so we have encountered data redundancy. And also, we have uh, seen also the compromised data integrity of the database because of those anomalies, the insert, update, and the delete anomaly. So that we could solve all of those, we are going to apply the technique database normalization. Okay? So there are different uh, normal forms of our database. Okay, so first is we have, by the way, we have the objective. The primary goal of normalization is to organize the attributes or the columns and the tables in a database. So in our previous example, we have used only a single table. And since we are using a single table, so therefore, there of course are different anomalies. Okay? By adhering to a set of formal rules known as normal forms, okay, so we have rules to be followed and they are called as normal forms. We ensure that the data dependencies are properly enforced by database integrity constraints. Okay? So as we go along with the different normal forms, so we will be introduced with the database integrity constraints. Okay? So we're going to have first our first normal form. Okay? A table or a relation is in first normal form if and only if, okay, the domain of each attribute contains only atomic or indivisible values. So when you say atomic, meaning single, okay, single values, indivisible, and the value of each attribute contains a single value from that domain. So atomic or single value. Okay? So it should not it should only contain a single value. Okay? Eliminate repeating groups. Okay, so we're going to have an example for this one. So I have prepared here an example. Okay? The same table that we have in our previous example, except that I added province and region. Instead of trying to have the address, I added the two columns here. So, if ever that we're going to follow the rules in the first normal form, this is not yet on the first normal form. Why? Because it has repeating values. It said that it must contain atomic values. Okay? So going back, so atomic values. So when you say each column or attribute, when you say attribute, by the way, it is the column. So all columns must contain atomic or a single value. In our example here, we have multiple various values for the subject code and the subject description. So therefore, this table here is not in the first normal form. Okay? So we are going to convert this table into the first normal form. So how are we going to convert this one here? So eliminate repeating groups in individual tables. Okay? So here, we have repeating values. So therefore, we are going to eliminate those. And I'm going to show you that is actually our first example. So we have, in our previous video, so we have this format here. Okay? So we could not see any non-atomic values in our table now. Okay, so therefore, we are now on the first normal form. Okay, so what we did is that instead that we are going to have multiple values here, we separated them into two different rows. Okay, and it said identify each set of related data with a primary key. As we have defined before, a primary key identifies each row, so it must be unique. But as you could see here, we have no unique values for our columns. For example, for the ID, so we have two records with 101. Okay, so therefore, this could not be our candidate key for our primary key. Okay, also with the names and so on. So therefore, we could not, all of the columns here do not pass the criteria of being the primary key. So therefore, in that case, we are going to use what we call as composite primary key. Okay? So we are going to make student ID plus the subject code as our primary key. Okay, so I'm just going to rearrange them, although we can do it this way, but I'm just going to rearrange. Okay, I'm going to transfer the subject code into there. Shift cells left. Okay, so this one here is our primary key. I'm just going to color it with, okay, so that we could identify that we have here our primary key. Again, it is called composite primary key. Okay, so therefore, this one here identifies this record. Then also this one and so on. Okay, so based on the rules into our first normal form, okay, it contains only atomic values. So there should be no repeating values in every attribute. And we have set our primary key. Okay, so no repeating values for each column, and we have now set our primary key. So therefore, we are now on the first normal form. Okay, but then, as we have observed into our previous example, we could see here now, or we could now experience those anomalies if ever that we are going to stay into this format, okay, in this form. Okay, so that is why we have here the second normal form. Okay, its primary objective is to further reduce data redundancy and ensure data integrity. Okay, as you can see, we still have, although take note, we could not totally eliminate data redundancy, but at least we are going to minimize it. Okay, so as you can see, we have data redundancy on the name, the province, and the region. Okay, so if ever Mira has, let us say, 10 subjects, so therefore, we are going to have repeating Mira Bini, Misamis Oriental, and Region 10 10 times. Okay, so that is why we have this second normal form. So to be in a second normal form, a table must meet the following criteria. First, it is already in the first normal form. Okay? Then, this is very important. There are no partial dependencies on the primary key. Okay. Partial dependency occurs when a non-prime attribute, when you say non-prime attribute, meaning it is not part of the primary key. So when you say candidate key, that is our primary key. A non-prime attribute depends on only a proper subset of the candidate key. Okay? It occurs, what's that? Partial dependency occurs when a column value depends on a single, not on the entire primary key or candidate key. So, in simpler terms, okay, so this is clearer. Every non-primary key attribute must be fully functionally dependent on the entire primary key, not partially. Okay, so into our example, by the way, okay, into our example here, we have partial dependencies. For example, Java, okay, or let us say this one here, okay, let's say Java or this are actually dependent on the subject code only, okay? And all of these are dependent on the student ID, okay? So here, because Java could not be dependent on the student ID, okay? But it is dependent on the subject code, okay? So there occurs a partial dependency, okay? So the solution here is split the table into separate tables, okay? So therefore, we are going to separate them, okay? So I'm just going to copy. First, I'm going to get for the student, okay, save it there. And I'm going to separate, I'm going to create another table for okay, the subject code and the subject description. Okay, so I'm going to remove okay. So I have now separated them into two different tables. Okay? So the next thing that we're going to do then is we are going to eliminate the duplicate shift cells of the duplicate values. Okay, 331 and so on. Okay, also with R, I'm going to remove and also shift cells up. Okay, so as you can see, I have now separated the two tables. I'm just going to call this one as TBL subjects. Okay, so as you can see, all of these are now dependent on our student. And this one here is also dependent on our primary key here. Okay? Then, so that we could know what are the subjects of each of these, so we're going to have, I'm just going to copy. Okay, stud ID and subject code. Okay? So, as you could see here, Mira has two subjects, okay? 231 and 432, okay? So therefore here, I'm just going to have 101 and 101, meaning Mira has two subjects. What are the subjects? We have 231 and 432, okay? So I'm just going to okay, no field. Okay. I'm just going to call this one TBL student subjects. Okay. The next is we have for Bea. So Bea has only one subject. So therefore I'm going to have here Bea is 205 and the subject of Bea is we have 333. So I'm going to have ITE 333. Then next is we have Marchams. Okay, so it's got two subjects, 231 and 345. So for Marchams is we have here the ID of Marchams is 239 and the subjects 231 and 345. ITE 231 and ITE 3, 4, 5. Okay? And we could just actually set this one as our primary key, or normally, by the way, we also have, usually, I create, for example, stood subject. I'm just going to call it this way with my prefix ID. And normally, I'm going to create this one as, oops, okay. So I'm just going to create this subject here as auto increment. Okay, so I could then just make this one as my primary key for this table. Okay, although as of now, you could just leave it as it is if ever that you don't want to have here our primary key. And actually, one of take note of this. One of the criteria for a primary key, although it is not actually 100% enforced, is that it should not be editable. It should not be updatable. Okay? Because what will happen? If ever I'm going to update this one, so therefore, you're also going to cascade your updates here. Okay? So because IT231, it is possible that this could be edited. Okay? But anyway, we're going to go deeper into that as we go along. But as of now, we're just going to have this one as our primary key. Okay? So how are we going to interpret this table now? So we have the stud ID here. So if ever that you are going to query, what are the subjects of Bini Mira? Okay? So since this is our primary key and we use it as a foreign key here, so therefore we are going to search for all stud ID from this table with stud ID as 101. So therefore, we would know Mira has two subjects. What are those? 231 and 432. Then, what is 231? So we are just going to look up to our TBL subject. So therefore, you could see there, oh, the description is Java. Okay? So how about 432? Again, look up. Then you could see there, the subject description is networking. And so on. We are going to say, who are the students who are enrolled in the subject Java. Okay? So, just look at for the primary key, 231. Then, look at then you're going to browse or query from this table all subjects, okay? All records with the subject code ITE 231. So, we could see this one here and the fourth record. Next, you want to know the name. So, go to stud ID, then refer it there. Oh, 101 is we have Mira Bini, and 239 is we have Marjams. Okay? So, that's how are we going to remove or eliminate the partial dependencies. Okay? So, take note. Subject description is dependent to the subject code. So that is why this one here is it is partially dependent to our primary key, because our primary key here is we have a composite primary key. Okay, so therefore we are now on the second normal form. Okay, then the third normal form is a level of database that builds upon the first and the second normal form. Its primary goal is to eliminate, okay, transitive dependencies within a table. So when you say transitive dependency, it says a non-prime attribute, meaning the ordinary columns, or when you say non-prime attribute, meaning columns that do not belong to the primary key. Okay? So meaning, let us just say, an ordinary column, meaning non-primary, depends on another non-prime attribute or non-prime column. Okay? Essentially, it means that an attribute indirectly relies on another attribute through a chain of dependencies. Okay? So that we could fully understand, we are going to analyze our second normal form. Okay? So, we are going to search for columns that are dependent on other columns. Okay? So, here, okay, so all columns are dependent to our primary keys. But how about into our TBL students? So, as I have said a while ago, all of these are dependent to the student ID. Okay? Uh, Theoretically speaking, supposedly, that should be the case. Okay? But in this case, the province is dependent to region. Okay? So, meaning, because if ever that we are going to go in every province, by the way, uh, they belong to a certain region. Okay? So, therefore, this one here is dependent to region. Okay? Or we could get region based on the province. Okay? So therefore, one here, something here, or a region is not dependent on our ID. Okay? So that is why, in that case, again, we must have to separate these columns. Okay? So how are we going to separate that? So I'm just going to copy the second normal form, and we are going to go to the third normal form. Okay. So this is not yet on the third normal form. It is because we still have some non-key attribute. Okay, or non-prime attributes or columns that don't belong to the primary key that are dependent, okay, on another non-prime attribute. Okay, so therefore I could create here. I'm just going to put it here. Okay, province 1, 2, 3. Yeah, just going to have it here. TBL province. Okay, so that I could have, I'm just going to copy. We have the province, and we are going to have our region. Actually, we could use the zip code, but I forgot if zip code is based on the province, so we could use actually as our primary key our zip code, but I forgot. I am not already familiar with the zip code. Okay, so I'm going to create here a province ID. Okay, so I'm just going to have my province ID as let us say as auto increment. Okay, so 1, 2. So we have the province. So we have there Misamis, Oriental, and Batanes. Then we have the region. We have region 10 and region 2. Okay, so I have created now my other table for this one here for my province. And instead that we are going to have the region here, so I'm going to remove the region, shift cells left. Okay, and instead that I'm going to use, actually we could still use this one if ever that we are going to set the province as our primary key. But it is safer if we are going to have an auto increment value here, because take note, province column is editable. Okay? So Misamis Orientalis, we have 1. And we have also here 1. And Batanes is we have the ID of 2. Okay? Then, actually, if ever that we are going to go farther, we could still have redundant values here, and also we could still experience those update anomalies and so on here. Okay, so therefore I could actually separate okay TBL regions. Okay, then I'm just going to have region ID and auto increment. So I'm going to have 1 and 2. So Misamis Oriental belongs to 1. Oops, no. We're going to have here. Still, we're going to have our region. Okay. This is the Misamis Oriental belongs to region 10, and Batanes belongs to the ID which is 2. Okay, I'm just going to move it here. Okay. Okay. Okay, so we are now on the third normal form. So as you can see, there are no more transitive dependencies. Okay, because a while ago, the region and province are actually dependent with each other, or vice versa, and they don't belong to the primary key. So therefore, they are considered as transitive dependencies. Okay, so what we did, we have created another table and separated them. And these primary keys now, by the way, this would be my primary key. Primary key. Okay. Okay. And this, by the way, these primary keys here are now used as foreign key into my province table. Okay. And by the way, all of these, this one here, the values that we have here are actually foreign key from the TBL students, and all of these are foreign key or primary key that are coming from subjects table. And again, this is a foreign key, okay? And the source or the primary key it comes from is we have province ID. And the regions is another foreign key, and the primary key it comes from is we have the region ID. Okay? So with this, you have now fully normalized our table into the third normal form. There's also a fourth normal form, but that's still that is seldom. It only occurs, let us say, one in a million times. Okay, it's not that frequent that it occurs. So normally we only are going to have only up to the third normal form. Okay. So now let us discuss how did we eliminate those anomalies. Okay. Now I'm just going to put it here. Before, we are not allowed to add. I'm just going to add a row here. Okay. Okay, as I have explained in the previous video with our insert anomaly, we could not insert into this table. For example, we are going to have a new subject, for let us say cybersecurity. We could not add it here. It is because it is possible that this would be null. Okay, so therefore, we could only add a new subject if ever there are already students who have enrolled into that subject. Okay, that's our insert anomaly. But in our example now, for example, we could now add ITE, let us say 567 cyber security. Okay, so we have now a record encoded into our database even though there are no students enrolled into this subject yet. Okay, but what makes me, or what's the reason why I could now add it, is because we have added a table intended for subjects. Okay, then update anomaly. Now, it is possible, for example, I have two Javas here. Okay, I have three Misamis Oriental here. Now, if ever I have, for example, I am going to change the value of Java into intro to Java, and I missed editing the other Java here, or the other related record. So therefore, there are now inconsistencies into my record. Okay, why? Because the 231 here is intro to Java, and the 231 here is only Java. So therefore, they are not the same. So we have now inconsistencies into our table. How about in, okay, let's go directly with our third normal form. It is not normalized. So what I'm going to do is I'm just going to change this one time, okay? Introduction to Java. Okay? Now, I am not going to worry anymore for the others that I am going to miss, because we have now a related columns here. Okay? 231. So we have here 231, 231. Either of these two, as they are going to look up to 231, whatever would be the current value for the description, that would be then also the description for these two records. Okay, we could see that when we are going to have our SQL statements, SQL commands in multiple tables. How about Misamis Oriental? For example, I'm going to change Misamis Oriental. Here, we must have to change 3 times. Okay? Here, I'm going to change only. I'm going to change Misamis, let us say, Occidental. Okay? So therefore, it has a province ID of 1, and it is being used here as the province of these students. So therefore, I'm not going to change anymore any of the columns on the TBL students. Okay? So I changed only one value here. Okay? Now, if ever we're going to have the delete anomaly. So when you say delete anomaly, if ever I'm going to delete dbms, okay? So I could delete all of this, okay? Which includes the record of Bea, okay? So here, for example, Bea withdrawn from the dbms class, okay? So I have here. So what I'm going to delete only now is actually this one here. Shift cells up. And the record of Bea remains there, and the record of the BMS still there. Okay? So we have now solved our one, or the delete anomaly. But take note also here. There would be another example of insert anomaly, is that if ever, let us say, I'm going to add here, okay, auto number 6, then I'm going to have 440 and 239. Okay, so 239, no, this is 440, and this is 239. So still Marcham's, okay? Then he has a subject 440. Okay? So I inserted a record here that is not present on the subject code here, the list of valid subject codes. So this is now again an insert anomaly. Okay, so why? You're adding something here, a value here, a foreign key supposedly must have a lookup value from the lookup table. So therefore, we have, this is what we call as, again, another insert anomaly. But anyway, programmatically, we could manipulate, or we could avoid this error. Okay. Another one, another anomaly is delete anomaly. For example, I'm going to remove Java here. Okay? So as I'm going to remove Java, okay, I'm going to delete, take note, I'm going to delete that record there. It has records into our TBL student subjects. Okay? So these are then are what we call as orphaned records. Why? Because they don't have lookup values anymore into our, or lookup record into our lookup table. Okay? So one solution for this is to cascade delete. Okay? So when you say cascade delete, as I'm going to delete a subject here, all of these will also be automatically deleted. But anyway, it is a case-to-case basis. Okay? So normally, what we are doing here is we're just going to deactivate this one here. But anyway, never mind first on how are you going to deactivate this record. But as of now, just understand the delete anomaly, okay, that I have said. Okay? Then the update anomaly will occur only, will occur here actually if ever we are going to update this value here and we are not going to update these values here. Okay? So that is why it is better if ever you are going to have your primary key as non-editable. Okay? So that we could avoid the update anomaly in a fully normalized table. But anyway, in our succeeding examples where I'm going to introduce to you how are we going to avoid the update anomaly into our fully normalized database. Okay? So, to recap, so we have here, this is not yet on the first normal form. Why? It is because we still have multi-valued attributes. Okay, it is not atomic. So when you say atomic, it must be single value. Okay, so this now in the first normal form because all of the columns are have single values and we have already defined our primary key. Okay, now it's on our second normal form. All attributes must be must be fully dependent on the primary key. So there should be no partial dependency. So here there is a partial dependency because this column here is dependent only on the subject code and not on the full primary key. Okay? And Mira is dependent only with the stud ID. So therefore, so that it would be on the second normal form is we are going to separate them into different tables. Okay? And the third normal form says that no non-primary key or non-candidate or non-prime attributes must not be dependent on other non-prime attribute. Okay? So region is dependent on province is dependent to region 10. So therefore, this is transitive dependency. Okay? So we have separated them again and we have now our database in the third normal form. Okay? So We are going to have more of these examples in our next video. So that's all for today, and I'll see you on the next video.